What we watch is a video of an example of a process called 3D printing. Now, you might have heard what 3D printing is, or you might have watched videos involving 3D printing, but what really is 3D printing? 3D printing, also known as additive manufacturing, is the process of creating three-dimensional objects from digital models. This starts out with the file containing the digital model being transferred to the 3D printer, and then the 3D printer processes it and starts creating or building the object layer by layer. These layers are created sequentially until the desired object is fully created. These objects usually are created by or from various substances or materials depending on what the desired structure, object, and what is the purpose of the created object. More on this later. The creation of the 3D printer was revolutionary, as this development allowed for people to create their own models and their own objects at the safety of their own home. This also helped other industries, one of them being the medical industry, to create prosthetics out of materials such as titanium to replace lost human parts, such as legs or knees or anything, as well as other industries such as construction and industrial industry, allowing to create materials and even whole structures entirely out of 3D printing. And lastly, as an example, the food industry, allowing for customization in the food we consume, and as well as the customization in the culinary scene. All of those benefits and improvements that it provided sounds very good, and the 3D printing process sounds very simple. But what makes it difficult? The process and complexities happen inside and not outside the 3D printing machine. And it has something to do with the chemistry and the chemical processes involved in 3D printing. Now, the chemistry is quite long. So, let me generalize all of this into three categories. First, being the key roles of chemistry into 3D printing. Second, the chemicals and the classes of chemicals used in 3D printing. And lastly, the various types of methods and processes of 3D printing commonly used in the modern age. Starting off with the key roles of chemicals and chemistry in 3D printing. First, material composition. The base material or substance that will be used in 3D printing, whether it might be metal, resin, or anything else, determines the structure, quality, color, and other characteristics of the created objects. Additionally, based on what type of chemical or substance that will be used, when it reacts with other substances used or the substances present inside the 3D printer, it creates chemical reaction or processes inside the 3D printer that might change or alter the result or the final object that will be created. Secondly, curing and hardening of the desired object. Different types of processes in 3D printing involves different types of chemicals and chemical processes, as will be discussed later. For example though, photoinitiators or a specific type of chemical present in the substance that will be used in a specific type of process. The specific type of process involves a substance coming into contact with the UV light in the machine of the 3D printer, and then supposedly if the machine the UV light from the machine and the photoinitiators present in the substance react with each other, it's supposed to harden, and this creates the hardening or curing of the object. If the desired object does not have the right type of chemicals, like the photoinitiator's concentration, it will not harden correctly, and the desired object's quality is not up to par. Third, just as important as the hardening of the object is the adhesion and cohesion of the object. Each type of 3D printing process has their own chemical process that is involved and chemicals involved, so that each layer of the 3D printing process will adhere or will have cohesion with each other. An example would be hydrogen bonding. In one of the specific type of processes of 3D printing, Hydrogen bonding helps each layer for resin 3D printing bond or adhere or magdikit sa isa't isa. Another type would be the melting that happens in another specific type of 3D printing, which melts each layer's surface to create a mechanical bond interlocking them with each other to form the object as a whole. And lastly, one of the most important reasons or roles of chemicals and chemistry in 3D printing is the safety and stability of the created object. Chemicals set and stabilize the object as well as protect it from other factors, an example being UV. Let's say the chemicals or the substance that you use is vulnerable or sensitive to UV light. Chemistry or chemical that you would add into the mixture of the 3D printed object would help prevent or the UV to affect the created final object. Now, with the key roles of chemicals and chemistry in 3D printing being discussed, we now go through the specific classes of chemicals specifically used in 3D printing. The chemicals and the classes of chemicals used for 3D printing. First, solvents. These types of chemicals are used for cleaning surfaces, dissolving support materials, smoothing prints, and thinning resins or inks in certain processes. Common examples of solvents will involve the following. Each of these examples have their own uses and pros and cons on why it would be used as solvents in the 3D printing process. Number 2, acids. Acids are used to remove metallic supports, etch or clean surfaces, and in some specialized cases help in polymer or thermoplastic post-processing. They're also heavily used for certain cleaning and finishing steps in metal 3D printing that will be discussed later. Number 3, bases and caustics. These include solutions like sodium hydroxide or potassium hydroxide that can dissolve water-soluble support materials in fused deposition modeling, which will be discussed later on during that part, and helps in post-processing certain resin-based prints. They're often used in support removal stations for 3D printers that rely on soluble filaments. And lastly, one of the most commonly used substance or chemical type in 3D printing is resins. Resin-based printing thrives on carefully formulated photopolymers. Properties like brittleness, flexibility, temperature, resistance, and other characteristics all hinge on resin chemistry. These are the most commonly used classes of chemicals, but there are more that contributes in the process of 3D printing. These involve the following. There is a lot of them. Now, knowing why chemistry is important and discussing the chemical classes that are used, let us now proceed to the specifics of the different processes of the 3D printing. I don't know what any of these means, so there are 5 types of 3D printers used, each with their own different chemical processes involved, as well as different objects that can be created from them. The most commonly used type of 3D printer is called Fused Deposition Modeling, or FDM for short. This type of 3D printing involves the use of thermoplastics and polymers as the material which is melted, then extruded layer by layer until the object is fully created. Sometimes, other filaments or chemicals are used to help with improved layer adhesion, flame retardancy, flexibility, and other characteristics that might be beneficial for the object. The most commonly used material for this type of 3D printing is what's called as polylactic acid and acrylonitrile butadiene styrene, each having their own different characteristics, pros and cons, depending on the type of object you want to be created. The second type of 3D printing, and the second most commonly used type of 3D printing, is what is known as stereolithography, or SLA for short. That's a big word, but what does it mean? SLA uses a liquid resin that is cured with a UV laser or projector. SLA is highly dependent on the synergy between the photoinitiators, which kickstart polymerization under UV light. This is present in the chemicals or substance used, and the resin matrix. That's a lot of words and complexities behind those sentences, but what simply it means is the chemical which reacts with the UV light allows it to harden during the chemical process, And then each time, layer by layer, this process is created over and over until the whole object is fully finished. Even slight tweaks to the photoinitiator concentration can drastically alter a lot of factors during the process, such as curing times or hardening time, print resolution, and the final mechanical properties and characteristics of the object. Some advanced resins used in this process, or SLA, include nanofillers or specialized dyes to improve mechanical properties as well as achieve unique aesthetic or color characteristics for the object. All these revolve around chemical formulation that is done before the process so that it will run smoothly during the process of 3D printing. Now, those are the two most commonly used types of 3D printing or processes or 3D printers. There are three more which are not as used but have their own uniqueness and different purpose on why they are used. The third being SLS or selective laser sintering. SLS fuses powdered materials, often nylon or polyamide or other materials, layer by layer with a laser. Similarly to the other previously mentioned processes of 3D printing, this is done repeatedly until the whole object is created. Moisture or added extremities or other materials that might be added in the powder can lead to defective prints, as water vapor can cause voids or inconsistent fusion between the materials. To add valuable characteristics to these fusions, chemical conditioning agents may be also added to the powder to reduce static or improve flow characteristics in the whole object. The fourth type of 3D printing is what is known as binder jetting. First, a thin layer of the substance or powder usually is spread onto the build platform. Then, an inkjet printhead selectively deposits droplets of liquid binder onto the powder to create the desired part of the object. This process is created or repeatedly over and over until the desired object is created. And last but not the least is metal 3D printing. Comes in the form of DMLS, EBM, etc. Metal powder is melted or sintered by high energy source, usually a laser or even more stronger electron beam, to form solid metal components. Additionally, certain advanced metal 3D printing processes involve binding metal powders with polymers and then binding them chemically before sintering. This approach, sometimes called bound metal deposition, heavily relies on carefully chosen solvents and adds to remove the polymer binder. Similarly to the previously mentioned type of 3D printing, this entire success of the final metal or created object depends on the chemical steps and composition being precise and accurate the whole way through. The five mentioned type of processes of 3D printing, as well as the others that are not included here, are all very useful. They have their own applications on which type of material they can create based on what substance. They have their own pros and cons and why they are used in the real world.